For decades, nuclear waste has felt like this unsolvable problem, right? This thing we just have to bury and hope for the best. But what if that's completely the wrong way to look at it? In this explainer, we're going to dive into some incredible technologies from private companies that are doing something amazing. They're turning nuclear waste from a liability into a real asset. So while we've heard a lot about these massive, slow-moving government projects focused on storage, something else is happening. A totally different story is unfolding, and it's happening at lightning speed in the private sector. These innovators, they've got this radical new vision. They're asking, what if we could actually eliminate the waste, or recycle it? Or, get this, what if we could turn it into something valuable? All right, so today let's take a tour of this incredible innovation ecosystem. We're going to look at 4 key areas that are totally revolutionizing the industry. First up, reactors that literally eat waste. Then we'll get into advanced recycling and, well, safer ways to dispose of what's left. We'll also meet the robots doing the really dangerous jobs. And finally, we'll talk about the guardians making sure everything stays safe for like millennia. All of this together, this is the new frontier of nuclear waste management. Okay, let's jump right into our first category, because honestly, this sounds like it's straight out of science fiction. We're talking about a whole new generation of reactors, and they're designed to use existing nuclear waste as their fuel. So the key technology that makes this all possible is called a fast reactor. And the whole concept here, it is a total game changer. Instead of just creating more waste, these reactors can actually consume the really nasty stuff, the most problematic, long-lived parts of the waste we already have. It literally shrinks the problem down. It's incredible. So who's actually building these things? Well, our first innovator is a company called Nucleo, and they are absolutely laser-focused on taking this tech from theory and the lab and putting it into the real world. So how exactly are they doing it? Well, Nucleo is developing what are called lead-cooled fast reactors. The really important part here is that these things are specifically engineered to burn the most hazardous parts of nuclear waste. What that does is it effectively closes the fuel cycle. And what does that mean for us? It means the stuff left over at the end is way less radioactive and for a much, much shorter period of time. All right, next up is a company you've probably heard of, TerraPower. Yep, the one founded by Bill Gates. They are another absolute heavyweight in this space, really pushing the boundaries of what a reactor can do. TerraPower is actually tackling this from 2 different angles. On one hand, they're building advanced fast reactors, and on the other, they're pioneering these really cool molten salt systems. Now, both of these designs, they share this one remarkable capability. They can run on something called transuranic waste. Just think of that as the most stubborn, longest-lasting gunk left over in spent fuel. It's the very stuff that makes long-term storage such a massive headache. And to round out this section, we've got one more company, Oklo. And they're taking a slightly different, but, an equally revolutionary approach to all of this. So instead of building these huge, sprawling power plants, Oklo is all about small, compact microreactors. The best way to think of them is like nuclear batteries. And their whole mission is to create these little powerhouses that can run directly on recycled nuclear fuel. I mean, just imagine that. They could effectively turn a waste site into a brand new local power source. Okay, so if these new reactors can burn waste, that begs a couple of questions, right? Where does that fuel actually come from? And what happens to whatever's left over? Well, that brings us perfectly to our next section, the companies that are focused on creating a real, honest-to-goodness, circular economy for the nuclear age. On this front, you've kind of got 2 types of players. You've got the established giants, like Orano. They're a world leader in processing spent fuel to pull out the usable stuff, like uranium and plutonium, so it can be reused. And then you have the trailblazers, like a company called Curio. They're developing these next-gen chemical processes to get even more useful materials out, while also neutralizing the really dangerous stuff that's left, making the final waste a whole lot safer. And, for that small bit of waste that still needs to be put away for good, even that process is getting a complete makeover. For years, the default plan was to dig these massive, super complex vertical mines, projects that take decades. But check this out. A company called Deep Isolation is borrowing technology from the oil and gas industry. Horizontal drilling. This lets them create smaller, much more flexible disposal sites deep underground, and they can do it way faster and in a lot more places. Of course, none of this works. Not the reactor fueling, not the recycling, not the disposal, if you can't safely handle this highly radioactive material. And that is where the robots come in. They're taking on the jobs that are just way too dull, dirty, and dangerous for any human to do. So, what does one of these robotic missions actually look like? It's kind of like a high-tech remote-controlled ballet. First, a robot with all these specialized sensors goes into a hazardous zone to map everything out to literally see the radiation hotspots. Then, with a human operator controlling it from a safe distance, it can get in there, handle materials, sort them, process them with incredible precision, and finally, pull them out for safe storage or disposal. And there's a whole crew of companies building these amazing machines. You've got Volia Nuclear Solutions. They make the heavy-duty robotic arms and systems that do the real heavy lifting. Then there's Boston Dynamics. You've seen their videos. Their adaptable robots are perfect for inspections in tight, dangerous spots. And then you have Cretech, who basically builds the eyes for these robots, these super advanced radiation mapping tools that have been used in huge cleanups like Sellafield and Fukushima. All right, so finally, even with these awesome waste-burning reactors and advanced recycling, some material is still going to need to be stored securely for a very long time. So this brings us to the last piece of our puzzle, the material science and the monitoring systems that guarantee the stuff stays safe for generations to come. And this isn't just one thing. It's really several layers of innovation. You've got companies like Haltech International, who engineer those incredibly tough dry cask storage containers. They're basically the gold standard for safety around the world. Then there's Mistras Group, who builds what you could call the nervous system for these places, advanced sensors that are constantly checking on the structural health of everything. And then, looking even further ahead, you have companies like Applied Ion Systems, who are researching wild stuff like plasma tech that might, one day, neutralize waste even more effectively. Okay, so let's recap. We've seen reactors that eat waste, we've seen advanced recycling, tireless robots doing the dirty work, and these long-term guardians ensuring safety. When you put all of that together, what you get is a powerful, interconnected ecosystem, and it's driving some serious progress. So what's really clear here is that progress is happening on 4 totally distinct fronts, right? Each with its own clear goal, from consuming waste all the way to ensuring long-term security. And I think the big takeaway is this. There is no single magic bullet solution. Instead, it's this whole ecosystem of innovators all working at the same time, pushing the entire field forward faster than we've ever seen before. So here's the bottom line. The nuclear waste problem, it isn't just being managed anymore. And it's definitely not being ignored. It is actively being engineered into a solution. We're talking about a future that is safer, cleaner, and way more efficient. I mean, the progress we're seeing is just incredible, right? It's all driven by human ingenuity and amazing engineering. But it really makes you wonder, what's the next frontier? Could we go even further? And that leads us to the ultimate question. Could artificial intelligence eliminate nuclear waste entirely? Next time, in Series 4 of our Explainers, we're going to explore exactly that, how AI could completely transform waste management, from optimizing recycling to maybe even designing reactors that produce almost no waste at all. I hope you'll join me for that.
Welcome to our exploration of nuclear energy myths. We begin with a provocative question. Is it true or false that reprocessing can actually recycle 96% of what we typically call nuclear waste? Let's dive into the science behind nuclear fuel and its potential for reuse in modern power. The answer is true. While the United States currently discards spent fuel as waste, France leads the world in reprocessing technology. By extracting uranium and plutonium, they recycle 96% of the material, significantly reducing the volume of waste and maximizing the energy harvested from every single fuel rod.
Our next challenge, true or false? Does nuclear waste kill more people than solar panel disposal? This question addresses the long-term safety and environmental impact of energy waste. Many assume nuclear is more dangerous, but the data on toxic waste disposal and environmental leakage might actually surprise you.
Surprisingly, the answer is true. Nuclear waste deaths are near zero because the material is strictly contained. Conversely, solar panels contain toxic heavy metals like lead and cadmium. If not recycled properly, these metals can leach into the soil, causing significant health risks compared to highly regulated nuclear storage.
We hope you are enjoying our nuclear series. Please subscribe, like, and share.
Thanks!